Hello students, as you can see on the board I have written trigonometric identities. So today we will be studying about these trigonometric identities. But before I begin the class, if I ask you, how many of you know the trigonometric identities? I think the number will be very less. But if I tell you, there is no need to memorize the identities, but you can derive it from the very basic knowledge, then I think it will be very interesting for you. So let's begin the class. We already know about the six trigonometric ratios, that is the sine, cos, tan, cosec, sec and cot. So first of all, we'll see how we can write this. This is sine. Okay, before this, let me tell you how the trigonometric ratios are related to the sides of a right angle triangle. So we can recall it like this. Some people have curly brown hair, turns permanently black. That means I can write this as sine theta is perpendicular by hypotenuse. Likewise, we have cos theta is base by hypotenuse. And then we have tan theta is equal to perpendicular by base. Right? And the remaining three trigonometric ratios are the reciprocals, like yesterday also I have given you in the class. The reciprocal of sine is cosec theta is the reciprocal of cosec theta is sine, or the reciprocal of sine theta is cosec. So this will become h by p. Likewise, the reciprocal of cos is sec theta is equal to h by b, and we have cot theta is equal to b by p. Now we'll see the right angle triangle. So this is the right angle triangle. This is A, B, C. This is the 90 degree. This triangle ABC is right angle at B. This is called the hypotenuse. Right? And BC can be the base or it can be perpendicular. AB can be the base or perpendicular depending upon the theta, the angle which we consider. So we know what is the Pythagoras theorem. Here we will be using Pythagoras theorem. We will use the Pythagoras theorem to derive the trigonometric identities. So what is the Pythagoras theorem? We know that for let's say I write this is perpendicular and this is the base. But as I told you, depending upon the theta, the perpendicular and the base can change. But the hypotenuse will always remain fixed. So we have hypotenuse square is equal to perpendicular square plus base square. Right? So, in very simple, let me write it as h square is equal to p square plus b square. Right? H square is equal to p square plus b square. Now, in the first case, if I divide both the sides by h square, right? If I divide both the sides by h square, dividing both sides by h square. So this will become h square divided by h square is p square divided by p square, sorry, I'm so sorry, this is h square plus b square divided by h square. Both the sides I am dividing it by h square. So h upon h is equal to 1. P upon h, you can see here. Where is p upon h? Here, sine. So p by h is sine, but because this is square, I write sine square theta plus what is b upon h? B upon h is cos. So I can write here cos square theta. So we have got our first identity. There is no need to memorize. If we just know the Pythagoras theorem, we can get the identity. The second one, again I will be writing the same Pythagoras theorem, that is h square is equal to p square plus b square. Now here in the first case I have divided it by h square on both the sides, and now I will divide it by dividing both sides by p square. So what we get, h square by p square, h square by p square equals to p square divided by p square plus b square divided by p square, right? So let's find it out here. What is h upon p? You can see h upon p. Here we have h upon p, that is cosec theta. So instead of this we can write cosec square theta is equal to p upon p, will divide, you will get 1. P square divided by p square is 1 plus, now we have b upon p. B upon p, here we have, which is cot theta. So I can write this as cot square theta. So we got the second identity here, right? So now we'll derive the third identity, that is, again I'll write here h square is equal to p square plus b square. I am using the same statement here, the same equation, that is hypotenuse square is equal to perpendicular square plus base square. In the first case you have seen both the sides I have divided it by h square. I got one identity. Second I have divided it by p square. I got the second identity. Now by this time you must have guessed with what I am going to divide in the third case. So I will be dividing both sides by b square. So what we get here, h square divided by b square equals to p square by b square plus b square by b square. Now what is h by b? Where is h by b? Here we have h by b, that is sec. So this is sec square theta is equal to what is p by b. Where is p by b? Here, tan theta. So this will be, sorry, this is square, this is tan square theta, b upon b is equal to 1. So we got the third identity as well. So if you just change the sides here, I can write it as 1 minus sine square theta is equal to cos square theta. I'll just shift the sine square theta towards the left hand side, right? Or I can also write it as 1 minus cos square theta. I'll get cos square theta to the left hand side. So what is left here? Sine square theta. Likewise, in this case, if I write cosec square theta minus 1. I'll take this 1 to the left hand side. This is cot square theta, or this is cosec square theta. Let me bring this cot square theta to the left hand side, minus cot square theta is equal to 1. 1 will remain. In the same way, here we have sec square theta minus 1 is tan square theta. I'll bring this 1 to the left hand side, and now here we have sec square theta minus tan square theta is equal to 1. Right? So in this way, we have derived this trigonometric identity. There is no need to memorize. You can derive it if you know the Pythagoras theorem. Right? So this is what is there for today. You try doing it on your own. It's very simple. In the next class, we will start with some application based questions on trigonometry. Thank you.